This is TWIS. This Week in Science, episode number 848, recorded on Wednesday, October 27th, 2021. Is this Spoopy science? Hey everyone, I'm Dr. Kiki, and tonight, we will fill your head with brains, disguises, and mummies. Uh-oh, but first, thanks to our amazing Patreon sponsors for their generous support of TWIS. You can become a part of the Patreon community at patreon.com/thisweekinscience.
Disclaimer, disclaimer, disclaimer. There are werewolves around here. There are werewolves around here. And they're waiting for the moon to appear. There are witches in the woods. There are witches in the woods. And I don't know what they're brewing, but I hear it's very good. There are vampires in this town. There are vampires in this town. And they're waiting for the sun to go down. There are mummies singing songs. There are mummies singing songs. And I don't know what they're singing, but the black cat sings along. There's a horseman without a neck. There's a horseman without a neck. And he seems to be mumbling. This Week in Science is coming up next.
I've got the kind of mind that can't get enough. I wanna learn everything. I wanna fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I wanna know what's happening. What's happening? What's happening this week in science? What's happening? What's happening? What's happening this week in science?
Arr, good science to ya, Kiki and Blair.
And a good science to you too! Like, oh my god. We're gonna go have a bunch of science. Let's get it, everyone. It's Twissoween! And we are so glad that you are joining us for another episode of This Week in Science. Blair's back from her
Looks like a Hawaiian vacation. Yeah.
Am I back? Or did I leave myself behind?
I think you have brought your vacation home with you, judging by your Hawaiian shirt, shade hat, bleached blonde hair, zinc-covered nose, and very large sunglasses.
Yeah, I mean, sun protection's important, you know?
But just on the nose, apparently.
Just on the nose.
Just on the nose.
I mean, that's a bit on the nose for heading out on a vacation. Anyway, yeah, Justin's brought a bit of the pirate flavor.
If I'm for further away, or maybe I needed a hat. From here, it just looks like I'm wearing like a fancy lounge jacket. But it's piratey.
It's a piratey lounge coat. It's for the pirate lounge. After you're done at a hard day at sea, you head into the pirate lounge. Yeah, I've brought a momentary tank girl.
Yeah.
Inspired.
Always welcome.
Yeah, my pink wig, my shiny shades, and a little pink furry vest because you gotta have fun outdoors. All right, everyone, now for the science. Okay. What do we have on the show tonight? I have no aliens. I have no neutrinos and brains. Because maybe I'm zombie tank girl. Could be. Justin, what'd you bring?
I have got mummies and lots of other ancient people stories.
Fantastic.
all mysteries of the ancient peoples being revealed tonight.
I love
all
it. You are I don't know, digging up the the treasure of the long dead past. Maybe on the show.
there
Sounds
you go.
sounds about
There you
right
go.
for a pirate. All right, come on. All right, hula girl. What is in the animal corner?
Oh, I brought rabbits in disguise. I brought hippos because I gotta bring hippos when they're in the science news. And then
Yes.
I also brought kissing prairie dogs.
Oh, that just sounds very
Prairie
sweet.
dogs.
Yeah, I can't wait. I love prairie dogs. All right, everyone. If you are in, you're in. But, if you haven't quite jumped in yet, you can subscribe to This Week in Science. Look for us all places that science podcasts are found. This Week in Science is what we're called. You can find us also on Facebook and Twitter and Instagram, YouTube, Twitch, all over the place. Some places we're TWIS, others TWIS Science. But you can always go to our website, TWIS.org. All right. Time to dive in to this big witch's brew of scientific information. All right, I'm going to start it off with aliens. There was a signal from far away that we thought could possibly be intelligent life elsewhere.
First
in the
contact!
universe.
We finally did it! Oh my gosh, what does this mean? Is this a great day for humanity, or is this the horror of knowing that there's others out there who might come soon and invade us?
Stop. Okay, so Breakthrough Listen, part of SETI, and anyway, a bunch of researchers had thought maybe they did find something out of Proxima Centauri, which is far away, but it's one of our closest neighbors, actually.
Close enough. Yeah.
Close enough, and it does have what we think could be life holding planets around its star. So we thought maybe, just maybe, but then the analysis went in and the researchers are like, let's go check everything again and see what happened. And basically it's radio interference.
Wait,
We're listening to ourselves again.
Sure.
What gave it away? Was it we finally deciphered the transmission, and it's like, well, all right, folks, be careful out there. There's going to be a lot of traffic on the 10 and on the 405 and on the 101, so stay off the freeways if you can. Like, was it just...
So the researchers who have published in Nature Astronomy, they say, that they really thought if you had detection of a signal that had a particular signature frequency change that only showed up when you were pointed at the source of the signal, then that's something that's pointed at you, right? So this is a special signal. That's it. But they have realized that isn't really the way it worked. So they had to go and peek at it a lot more, and it does really just turn out. They used machine learning algorithms to figure out that it was interfering equipment, and they were able to determine that it's us. That's it.
Has anybody else noticed
Sorry,
that whenever...
no aliens for Halloween this year.
Has anybody else noticed that we always get the signal when Jan is making popcorn in the microwave? Because it seems like there's a little bit of a correlation there. I don't know if anybody else has noticed.
Yeah, the researchers say the frequency of the signal drifts in a way that is consistent with inexpensive crystal oscillators, such as those commonly used in computers, phones, and radios.
Kind of stuff you'd find all over a research lab.
Well, wasn't one of the very first times we thought we got a signal from aliens, it was pigeons?
Right.
No. So
There's
what that
one.
No, there's what you're talking about is actually the discovery of the microwave background radiation, which the researchers thought that the signal was interference, and so they went up on the roof with shotguns and cleared out pigeons. And cleared out pigeon poop and got rid of all, and then they still got the signal, but they didn't know what they had. There was another lab that was actively looking for the background radiation that couldn't find it, and here they just were like, hey, we got this signal. And then somebody some more learned researcher, I think, in the department went, I think I know what you guys got, and you need to publish right away. Right away. Because it's big.
It's big, but this is not big. It's not aliens, but at least we're learning more about how we interfere with our search for aliens, which will allow us to pinpoint that potential signal in the future that we've been waiting for. Yeah. Tell me a story.
Or not
Justin.
waiting for. I'm stuck.
Do we really want
I'm
to?
very much on the fence because, the history of at least humans going someplace where they have a technological advantage over other humans has literally never ended well for the people who are being visited. Like,
I don't know. At some point, maybe we're just going to get like the spam calls from an alien civilization.
Oh, you think? Oh, gosh. An entire planet of scam marketers?
Yeah.
Oh, no. That would not be okay.
Yeah.
Justin, what do you have?
What do I have? Oh, so this is kind of an interesting story. Part of the Silk Road. This is an area geographically intersecting Eastern and Western cultures. It runs from all the way through the Western Asia to Eastern Europe, and was for many 1,000 years plus a trade route through which all sorts of disparate cultures and peoples, agriculture, language. There was a great deal of our language, common words within languages that were formed there. It's one of the reasons we have very similar words for things like water and different kinds of food. They're shared amongst languages throughout much of the world because these were very important things to be able to get across. Like, my horse needs water, my camel needs water, I need something to eat. So it's this very storied area of the Silk Road, right? So back in the 90s, they discovered hundreds of naturally mummified human remains that are about 4,000 years old in the region of Tarim Basin. And so there was this sort of interesting, a lot of speculation around who these people were. They were thought these mummies had very Western physical appearances. They had slightly different types of clothing. There was felted wooden woven clothing. They had cattle and sheep, goat, wheat, barley, millet. They had cheese. They had stuff that seemed out of place, although over time they discovered actually those were pretty common in the area. They were less uncommon than had originally been thought. But they were buried in boat coffins in the middle of a desert. Also a sort of an interesting twist. Why do these people have boats in the middle of a desert? Why would they bother bringing their boats with them? So these the Tarim Basin mummies have been a long enigmatic mystery. And so eventually, there's all these ideas. They thought they might be descendants of there's this known group of Yamnaya herders who moved around. There's a Bronze Age society of the Black Sea region of southern Russia. That could be them. It could be some Central Asian culture that was traveling there, but nobody really knew. I mean, even groups as far down as the Iranian plateau were rumored to have been responsible for being these people. And then something got invented and finally got applied, which is they did some DNA testing. Oh, thank goodness for the DNA testing. Because with all the myriad of theories about who these people could be, the DNA analysis has come back with some very interesting results. They took, this is a lot of universities. This is, Gillen University, Institute of Vibrate Paleontology and Paleoanthropology, Max Planck Institute of Evolutionary Anthropology, Seoul National University, Korea, Harvard University. Lots of big brainy people got involved in doing the analysis. And they took some of the oldest mummies in the area, and they took a bunch of the even older remains from some of the surrounding neighboring basins and cultures. And they found, to their surprise, the Tarim Basin mummies were not related to any of the ancient neighbors. In fact, they don't have any admixture with the peoples that had populated the region of that time. They don't seem to have mated outside of their group. they're saying this is a very isolated population because it's rather uncommon for a group that persisted for maybe 1,000 years, or at least many hundreds of years in the region, to have had no admixture, at least in the oldest mummies that they analyzed. They did come back as being most closely related to what is known as the ancient North Eurasians. This is a group that is thought to have been sort of widespread, but they only have a few really good examples. One is from a 24,000-year-old boy that was discovered in Siberia. The population on the planet that has the greatest relationship, the highest known proportions of shared DNA with these 4,000-year-old people, mummies along the Silk Road Uyghur territory. Native Americans have a 40% hit.
Oh, wow.
Yeah.
That's fascinating. All right. So what does that tell us?
Well,
right.
So it means that humans started in North America and migrated to Asia. Well,
no, I don't think that. Yeah.
Well, it actually could. It could mean that this is a population that made it all the way to the Americas and then came all the way back.
Died. Oh.
And came all the way back. Because you're only talking 4,000 years ago now. And now we know native North Americans going back 30,000 years.
Mm-hmm.
The idea that they traveled from one continent to the next and throughout that continent, and nobody ever went back. Nobody ever went the other direction. So that's a possibility. Another possibility is this is an isolated group that was connected to the first North Americans. Problem with that, though, if you think about it, is this is only 4,000 years ago. This is only 4,000 years ago. Whereas the oldest member of this group that has been found to be solidly of this group of isolate is 24,000 years in Siberia, which sort of matches that from Siberia over to Alaska and down. But at 4,000 years ago, with 30,000 years of history in North America, there's a great chance that this group traveled the other way, and it would explain having boats. It's hard to explain a group that comes from Siberia down into the Silk Road who bothered to bring boats with them, unless they were a people who had traveled some vast distances with their boats, and no matter where they are, they're still need to bring they're going to bring those boats with them because they're going to
come against water again at some
eventually.
Or to eventually go home. Or eventually to head back again. The boat needs to be important to you, even if you're in the desert. If you need to connect, you're thinking maybe one day I'm going to catch that connecting.
Was it a desert when they all died?
So at 4,000 years ago, they have still a pretty decent idea of that it was still kind of a desert territory. Okay. The Silk Road was, except for all the humans traveling, could be disparately, it could be have sort of all sorts of disparate climate along that road. But for the most part, and certainly where they were in the desert. Wow. And if you look at that boat, it's kind of a carved out canoe looking thing.
Like a canoe. They're portaging.
Yeah.
Mm-hmm. Yeah. And you can use your boat to carry a bunch of your stuff, and you're multi-purpose.
So the next thing I wanted to...
what's next?
So one of the other things is... there's also something that they found some cultural evidence that there was a belief that there was a dog guarding the afterlife. Which is something that goes into Native American territories. But it is also something that happens in Norse mythology to an extent.
Yeah.
And one of the mutations they found in one of these, what are they called again? The ancient North people, whatever, is one of the first mutations for blonde hair. So this is a group also, right? That's in the more ancient. This could be a group that disparately went up into Siberia and then traveled along a sort of northern band. the one thing that's missing from this that I'd love to find out is if there's any evidence that they had dogs with them. Because
4,000 years ago, they might have.
Yeah.
Why not? They would have helped.
I mean, something to pull the boats. So what? Something, because there's something to pull those dang boats. Because otherwise, that's a lot of
You just row through the sand.
That doesn't work very well. It's just not going to work very well, Blair.
But an extremely surprising find. Not something that when they went looking to reconstruct the origin of the Tarim Basin mummies, they had no idea that their biggest hit was going to be North America.
That's fascinating. It really makes you think about the movement of humanity, where people have gone. Yeah. Yeah. Super cool. Thanks for that story. Mummies! Perfectly in tune. All right, Blair.
Yes.
You've got a costume. You've got rabbits with costumes?
Yes.
Okay,
so
tell me a story.
Snowshoe hares. I'll talk to you about snowshoe hares. A team of researchers from multiple institutions throughout Canada have been looking at snowshoe hares because they are an animal that changes their costume with the seasons. So during the warm months, they're brown and dark, which helps them blend in. But as autumn passes, the dark fur falls out. It is replaced with white fur, which allows them to blend in with snowy backgrounds. Snowshoe hares are one of the classic examples of this. There's also Arctic foxes that do this and some other animals as well. But the big problem that these animals that have seasonal changes in their fur would have is climate change because depending on whatever signal they're using to change the color of their fur, that climate change might be causing problems. And so previous research with snowshoe hares has found that at least for them, it's tied to the amount of daylight, not the temperature outside. So they're going to change to white whether or not the temperature has changed enough to start snowing. It's all about their circadian rhythms.
Oh, that's going to end badly then.
You would think. However, how's this for some good news? Or what was it?
Good. I'm so glad somebody brought good news.
There we go. So they're actually doing great. For the first few weeks of winter, they are standing out starkly against the dark snowless backgrounds. They have these bright white coats. You would expect that they would be snatched up and eaten immediately. However, they tracked 347 hares using accelerometers as they progressed through seasons from 2015 through 2018, and they found that the mortality risk for hares during the autumn months actually was reduced by 86.5%.
What?
Why? Most likely it is because they foraged less because they had a warm coat on and therefore didn't have to burn as many calories keeping warm. So they were actually exposed less.
Oh, wow.
Yeah, so they found from these accelerometers they were foraging between 17 and 77 minutes less daily during the autumn changeover. So that means that hour less exposure every day is enough to reduce how easy it is to get eaten.
Yeah, less owl-fox exposure kind of thing going on.
Absolutely, yes. So their metabolism rates were lower because they were wearing their warm coats. So this is interesting for a couple reasons. So one being that, like, evolution usually has a pretty good handle on this kind of stuff, right?
Yeah.
If it would be better to have a thicker coat, more important than to be camouflaged, you would think this would have shook itself out by now. However, this weird fluke of rapid climate change has exposed this odd strategy that we have not yet seen. And therefore, this might actually push evolution in a really interesting direction in response to climate change.
Well, that really is just good news. You know what occurs to me, though? What about all the things? They're getting predated on less. What about all the animals that rely on preying on them?
Good question. So if it's something like an Arctic fox where they also are going through the same thing, perhaps it doesn't matter.
Because there's a larger Arctic fox population, there's a larger rabbit population, hare population.
Arctic foxes don't need as many calories because they have
Right.
the thick fur. So yes, so there's all this weird
Maybe it all balances out.
possibility that it could potentially balance out. That is assuming that other animals that predate upon them have similar advantages. I don't know for sure what the cue is for all of the predators in the area, if they are related to daylight or if it's temperature, because that's not unique, or that's not universal, I should say. So
I think with a
there's a lot of
carnivore,
weird
we
things.
got that. I don't know. I have a feeling if there's less of them getting eaten, hopefully there'll just be more of them. So the foxes and the owls and the what have yous have a chance. Because if they're just staying in the burrow all day, and the poor little
They're not
foxes
staying in the
wandering
burrow,
around
though. They
looking
don't have
for
to stay in the
food.
burrow. Get out.
Just worried about the foxes.
Yeah, well,
and the
I
owls.
mean, keep in mind, rabbits live like 2 to 6 years, so it all shakes out. It's
But
fine.
they
Okay.
multiply like
Rabbit.
rabbits.
Yeah.
It all shakes out in the wash. And
Nature
we'll
figures
see.
it
I
out.
think the interesting thing is to see how this moves forward with climate change and changing temperature
Mhm.
zones, changing habitable zones, and
Yeah.
rabbits
Yeah,
can
and it's-
move, but how far can they move, and what will they need to do?
Yeah, and I think on the whole, we're looking at a mass extinction event. We know that.
Yeah, yeah.
But there are situations.
That's scary. Talk about
where-
Halloween.
Yeah, I know. There are situations where there's going to be weird, new, and extreme evolutionary pressure.
Yeah.
So there are weird adaptive radiations that we will see as a result of climate change. It's not going to balance out the bad
People
stuff, but it's still,
wearing
we'll
more
see some interesting
gloves.
stuff. Yeah.
It's gonna
Dye
be
in their
really
hair.
interesting. Yeah. Very cool. Let's see. How Twissoween, I've got a big bowl of candy for all the physicists, but you know what? I'm gonna give them a box of raisins or an apple because there's
That's a
no
good thing.
sterile neutrinos, according
Ah.
to the microboon experiment here in the United States at the Department of Energy's Fermi National Accelerator Laboratory. No sterile neutrino candies for the physicists.
Well, no sterile neutrinos. Well, no wonder there's so dang many of them.
I know. So there are 3 neutrinos that are known according to the standard model, and they switch between their different flavors all the time. But there was evidence from another experiment called the mini boon experiment, an energy signature that hinted at what researchers thought could be a 4th neutrino, which they were calling the sterile neutrino. And if it were real, it would mean not standard model, not standard physics.
Dun,
It would-
dun,
Yeah.
dun, 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 dun.
So the physicists went back to the drawing board. They made a bigger, not a mini boon, it's a micro boon, but it's a bigger experiment. So anyway, it's this experiment was meant to test using liquid argon time projection chamber to be able to really see how these neutrinos, which usually are neutral and they don't really interact with anything, yet we think they might be involved in like why there's more regular matter in the universe than antimatter in the universe. So we think they're really important, but they tend to just pass right through stuff and they don't interact with anything very well. But these liquid argon TPC chambers, this experiment could have just really figured it out. And so they got a whole bunch of data out of this over the last few years. And it took them a long time to crunch all the numbers. And finally, the data is out. And that's it. 3 kinds of neutrinos: the electron, the muon, the tau. No sterile. I'm sorry. No extra candy for Twissoween, physicists. It's standard model or bust at this point.
Now go back and
Yeah.
think about what you did.
Well, okay, to be fair, every time when they got that signal originally, it did
They
correlate
thought it was
to
pigeons. Oh.
Janet making popcorn in the micro.
Yeah.
Would you stop with the popcorn running when we're doing the experiments?
I mean, you
kept
plug it in and you
interfering.
unplug it and you plug it in and you unplug it. It's kind of
But
fun
right,
messing with the physicists.
Yeah. So I guess what was it? What was the thing that was in the original experiment that ended up just being loose photons or something?
So that's the what they're seeing now is that these are photons, and this 170-ton neutrino detector has just it's gone against the original evidence from 2010 that had that anomaly, that they thought it could be photons, but it could also be something else really cool, and they had to test it out and see, right? You got to check all the possibilities. And this low energy excess is what they call it. It's not sterile neutrinos, and the researchers who are involved in publishing this work, they say, yep, now we know that it's photons. That's it. Not electrons. Yeah. But the researchers are still very excited because we've moved science forward. You disfavor a hypothesis, you go, oh, that hypothesis is not right. Now we know a little bit more about the universe. We can figure things out some more.
Yeah, except then they found out that you're going to give them raisins. Nobody wants raisins.
Come to my house for
nobody likes
Halloween.
raisins.
I'm going to give you apples and raisins, not even caramel apples that you can lose your teeth in.
An apple's okay, but a raisin?
Raisins.
Not a fan.
Not a fan at all. Tell me what you are a fan of. Do you have another story?
Oh, what am I a fan of? A fan of 1876. That's when the U.S. military waged a preemptive strike on Native Americans in South Dakota on land that had actually been ceded to the Native peoples for hunting and foraging and all that kind of stuff. One of these, there was a reservation, but then there was all this other land that was like, here, this is yours to go hunt in. So yeah, there was the Battle of Greasy Grass, which is alongside Yellowstone, the Bighorn River. It pitted Major General Custer's 7th Cavalry Regiment against a gathering of the Lakota, Northern Cheyenne, and Arapaho tribes that were led by Crazy Horse and Sitting Bull. Now, they had gotten together to sort of discuss some land management stuff, what to do with the new hunting grounds, how to, sort of a multi-tribe get together to talk about stuff. When the 7th Cavalry, with the element of surprise, sent troops down to start firing on the village unannounced. Little did they know that they weren't just attacking one small village, but a gathering of tribes. They were quickly outmaneuvered and overwhelmed. Most of the 7th Cavalry, including Custer, died that day. The battle, I think, they say it lasted as long as it takes a hungry man to eat his dinner, is how it was described by one. So more than half
was pretty quick.
It was pretty quick. There was initial flurry, and then the battle against Custer was over pretty fast. Half the 7th Cavalry was killed, the rest fled. And when the battle was won by the Native peoples, and the larger war eventually would be lost, Sitting Bull was there, of course, as one of the leaders. He went on to have a very storied life and was eventually assassinated in 1890 by the U.S. government. A man claiming to be the great-grandson of Sitting Bull has been asking for his remains to be moved to a different ancestral land. Saying he's not Lakota, so he wasn't from the South Dakotas, he was from a different area. According to the family oral history story. So, moving the remains of legendary figure is not something that is easily accomplished. For starters, there are actually 2 burial sites officially listed for Sitting Bull. One at Fort Yates, North Dakota, and another at Moorbridge, South Dakota. It is considered unlikely that he is buried both places. Secondly, are the man, Ernie LaPointe, and his 3 sisters actually the great-grandchildren of Sitting Bull? That has to get determined too. So a lock of hair from Sitting Bull had sat in the Smithsonian Museum for almost 100 years. It was returned in 2007. And the story about this caught the eye of a Danish researcher who's been mentioned many times on the show, Professor Aske Willerslev. Quoting here, "Sitting Bull has always been my hero ever since I was a boy. I admire his courage and his drive. That's why I almost choked on my coffee when I read in a magazine 2007 that the Smithsonian Museum has decided to return Sitting Bull's hair to Ernie Lapointe and his three sisters in accordance with a new U.S. legislation that was giving back stuff that was in museums that didn't belong to them. I wrote to Lapointe and explained that I specialize in the analysis of ancient DNA, that I was an admirer of Sitting Bull, and that I considered a great honor if I could be allowed to compare the DNA of Ernie and his sisters with the DNA of the Native American leader's Hare when it was returned to them. It ended up taking 14 years to find a way of extracting any usable DNA from this, this lock of Sitting Bull's hair. And they had to actually wait for new techniques to come around, as well as develop new techniques to be able to get the DNA and to do the analysis. And the results, just like most people who imagine they are related to somebody famous through family oral history and birth certificates, they were 100% correct. Ernie Lapointe and his sisters are the grandchildren of Sitting Bull. The new technique that was developed here could actually be used for old DNA that might previously have been considered too degraded to analyze. Anything from analyzing ancient historical site burials to modern forensic identification of maybe cold cases or a found body that has been there for seemingly too long. And this whole thing this hair, by the way, had been sitting in the museum, like on a shelf or something like this, room temperature for almost 100 years.
Wow.
So this is not
I mean, very often in the Smithsonian, they've got things at least preserved behind UV tempered glass so that it's going to be blocking at least the degrading rays of the sun. You're indoors where probably not getting a lot of light anyway. So,
but if you were preserving something like this with the intent of doing a DNA analysis, you would have just frozen it, right? Or that would have sealed it, froze it, and not touched it.
Right. They didn't have Smithsonian room temperature is probably lower than like the standard male likes the office temperature to be, or Wow,
that's very specific. Somebody having problems with the workplace thermostat?
Nope.
Okay. But it could be used for a lot of things. So the next step is they actually think they can use this technique on the two burial sites, the two presumed burial sites, to determine where Sitting Bull is actually buried, so that he can be returned to the proper ancestral ground, because Sitting Bull was a massive travel. He even took his tribe up to Canada at one point, always refused to sell land or negotiate with the U.S. government. This research, interestingly, was funded by the Danish National Research Foundation, funding research in the Americas that the U.S. government is not interested in learning more about, apparently.
It's all the stories you want to tell, right? The stories are told by the people with the funding.
Yeah.
Good. I'm glad this story is getting told, though. It's fascinating. This kind of historical work is always very interesting. Speaking of history, I've got big fangs. Big fangs. But not really fangs. Maybe more like very long teeth. They're tusks. So not really fangs at all, more just tusks. I've got tusks.
You're really walking back your headline.
I know. I'm sorry. Sorry, not sorry. Researchers have just published in the Proceedings of the Royal Society B, on their work to trace back to the progenitor of tusks. Where the heck did tusks come from?
Mm-hmm.
There are many mammals with tusks. Blair, can you name some animals with tusks?
Walrus, hippo,
Yes.
elephant,
Yes.
Hippo?
Barbarossa.
Wait, back up. A boar? Wild boar?
Boar.
But a hippo has
That makes
tusks? I
sense.
thought they just have big teeth.
No.
Ah.
It's ivory.
Oh, no.
Hyraxes, warthogs.
Oh, yes, hyraxes. Little elephants.
Warthogs?
Yes.
Yes. All right. So,
Huh.
what exactly is a tusk anyway? These researchers realized as they were trying to figure out where tusks came from that they're actually considering a tusk has been fairly ambiguous in the animal world for a long time. And it's just kind of like these extra long teeth, and sometimes it's a tusk and other times. So they defined a tusk or tusks. They have decided that it has to grow throughout an animal's entire life. So it can't like grow and then stop. It has to continually grow. And the surface is made of dentine rather than having a hard enamel like our teeth. Our teeth, they begin as dentine, but then they get an enamel coating. And so that does not happen with tusks. And so when they made this distinction, they were able to weed out a bunch of animals from the tusky corners of the phylogeny so that they could figure out who have tusks, who don't have tusks. Rodents don't have tusks. They just have very long teeth, for instance. And they have determined that going back about 270 to 201 million years ago, the dicynodonts are the ancestors of the tusk in mammals. These are the first organisms that got tusks. Dicynodonts were kind of mammally, kind of reptilian. They were they were a little before or right around the dinosaur age, and they were creatures that didn't all get tusks. In fact, it was kind of convergent evolution throughout the dicynodont family.
They're cute. I'm looking at photos. They're very cute.
Our current understanding of what they would have looked like, they got big fangs. I mean, tusks come out of their little roundy faces. Yeah. But if you look
adorable.
Up fanged dicynodonts, these were where tusks came from. And now we have a true definition of tusks, and we can understand a bit more about the evolution of teeth and where tusks came from and the ecological factors that would have led to the development of tooth-like toothy appendages. So you're going to have a need to use these teeth very regularly. Hence, they keep growing throughout life. They don't have that hard enamel shell like elephants. They use their tusks as tools. And there is a little crossover between this study and the study, another study that came out this week that found that there is a group of elephants that have lost their tusks due to evolutionary pressure. This group of elephants was hunted down to very, very small percentage of its original population. And naturally, there was 6 to 7% of the population that was born without tusks. But after the population went through this bottleneck, it created a real issue. And so now you have a whole bunch of elephants in the population who don't have tusks. Now, this happened in Mozambique, and researchers looking into the tusks of elephants determined that it is a genetic issue that is dominant and recessive. So what's happening is when females have this dominant gene, they end up tuskless. However, the recessive part of it is if males end up with the other gene, then they die. So it is linked to male lethality.
Oh, gosh.
Tusklessness leads to male death and female survival, just no tusks. And they tied it to a couple of genes that are related to enamel production and also dentin. So these are very interesting things to be looking at, specifically in the here and now as we're watching adaptation and evolution take place in response to environmental pressures like the hunting and killing of these elephants, leading back to where tusks originated and why in the first place, and how the genes have been involved in this tooth formation versus tusk formation for so long, over 200 million years. Yeah. Dicynodonts with tusks to now elephants without.
I'm obsessed. I'm going to keep this page of Dicynodont pictures open forever. Just look at it when I'm bummed.
Just look at the cute little Dicynodonts.
It looks like a mixture between a hippo, a naked mole rat, and a triceratops.
That.
Yeah, it's got a very triceratopsy kind of face.
Yeah. Oh, they're cute. This story is getting a little long in the tooth, though, so...
Oh my goodness.
This is This Week in Science. Thanks, everyone, for joining us for another episode of Science Fun on this Twissoween episode. We do hope that if you are enjoying the show, that you will share it with one of your friends. Additionally, we hope that you will head over to TWIS.org and click on the calendar. Blair's Animal Corner 2022 calendar is now available at TWIS.org. Get your calendar. Plan for 2022 today. All right. We're going to come back for a very, 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 very quick COVID update, because this is the one piece of news that has me excited this week. The FDA panel that has been looking at the 5 to 11 Pfizer vaccine dosage safety has recommended that it be allowed and authorized for children in the United States.
We just need CDC then, right? That's all we need?
Yeah, so we're waiting on the CDC, and the states are currently, the White House is working on getting doses out to the states. The states are working, hopefully. I mean, this happens all the time. I'm like, please, actually, system be working.
Yeah.
You're supposed to be doing the work to get the supplies where they're needed at this moment in time. So I'm really hoping that's happening. A big question that I've seen people ask, and I know people, there was a New York Times article about this as well. If your child is 11, going on 12, it is better to get your child vaccinated now than to wait until they turn 12. If you're worried about the third of a dose, 5 to 11-year-old dosage versus the full dose, 12 and up dosage, something is better than nothing. It seems as though the antibody titers that they're getting in the age group are great. And so having immune protection is going to be better, especially coming into the holidays, than not having it.
Yeah, I don't regret getting the J&J vaccine for 1 second, because I got what I could when I could, and I was protected sooner.
Yeah. And now you can mix and match. You can get another J&J.
I made my appointment. I'm going to get a Pfizer next week.
What are you getting a Pfizer? Moderna's the good one. That's you're in the wrong team.
They're all good.
It's the better one, though. It's not that you can pick and choose.
I picked the one. I picked the mRNA I could get soonest. Is what I picked.
Yeah. No, good choice. But I was kind of joking about this last week, but there's been like enough of a I don't know. It's just negative press or less positive long-term resulty stuff where I wonder how many people are going to go back for a second J&J.
I mean, we ran into people on our honeymoon that were saying they were going to go back for the J&J.
Okay.
Round 2.
And the side effects still are rare. We hear about them because the media loves sensationalism. And the effectiveness of the J&J added, the second J&J dose added to the first, brings it up to the effectiveness of the initial Pfizer dosages. So it's basically like, oh, you had your 2 shots just spread out over a very long time. The effectiveness does increase to about 96%, which is amazing. So, but the FDA in the United States has also said, mix and match if you would like. So if you are concerned about side effects, you have more choices at this point in time.
Give me that mRNA.
Which is great.
I'm so excited.
I know. Yeah, I'm like, I had the mRNA, and I'm like, well, maybe I should get a J&J. Maybe that's the one I'm going to go for next, just to have the
Just
full.
walking down the vaccine buffet line. Oh yes, a little
I'll
bit
take
of
one of
that. Oh yes, a
those.
little bit of that.
Take one of those. Oh, it'll be so good. Okay. Well, on that note, if anyone does have questions about the vaccines, about COVID-19, SARS-CoV-2, please let us know, or do definitely check the CC website for information. It is time now for that time of the show that we love, that we missed so much over the last couple of weeks, but that's back now. Hula Girl Hang Time! Oh, wait, what? No, that's not the what? No, oh, sorry. It's time for Blair's Animal Corner.
With Blair!
She loves our creatures, great and small. Biped, millipede, no pet at all. If you want to hear about animals, she's your girl. Except for giant pandas and squirrels.
What you got, Blair?
Did I get it all? There we go. Okay.
What? You trying to take that zinc off? Don't you
No,
dare.
I'm putting more on.
Okay, good. Cover it up.
Anyway, let's talk about hippos, shall we?
Yes, please.
So I took my sunglasses off so I could do this science for real. So hippos, just the gift that keeps on giving. So I want to talk about renowned zoologist, Cambridge University professor Richard Laws. He sadly died in 2014, but his friend David Walton, a scientist at the British Antarctic Society, or British Antarctic Survey, got a hold of Richard Laws's studies. He had a scientific legacy from 60 years of hippo research. From Antarctica, no hippos there, but all the way up to African savanna. So he studied a lot of animals, but he had specifically a huge stack of notebooks about hippos. Notebooks, maps, scientific data, all sorts of amazing stuff. He had rare and detailed measurements of almost 3,000 hippos collected from 1961 to 1966 in Uganda, and all of them were neatly recorded and categorized. And so this research was going to be tossed, but instead it was handed off to a group of hippo researchers, because this was the perfect opportunity to look at hippo body size. Now let me tell you about hippo body size. They're unusual. Why do you think they're unusual? Either of you? Any guesses? What's unusual about a hippo body?
They have a very large mouth.
They do have a large mouth.
And a very small tail.
That spins when they go poop.
Yes, that sprays poop everywhere. Very
Yes.
good. But what's really interesting about them is that the males are so small.
Oh.
Even though hippos can weigh 6,000 pounds,
Wow.
the males are small. That's because, according to other size ratios of male to female size differences in other animals that are similar, that are one male with a large harem of females, that are semi-aquatic. All these things will lead you to believe that these animals, the males, should be huge compared to the females. Polar bears, males can weigh 1,000 to 1,500 pounds. Females are only about 500. For elephant seals, they can weigh way more than females, around 6 times larger than females. So there's all sorts of kind of size disparity between males and females in these other examples.
And I guess in part of that, the one of the reasons that the males are so big is they have to fight other males for their harem. So they're constantly having to defend themselves. So the bigger you are, usually the better you are at surviving and having more offspring, because you can fight off the other males better if you're bigger.
So you're half right.
Usually.
So it's a
I don't know what about the hippo. But...
No. So the reason that you're half right is that it has to do with fighting other males for dominance. But the kind of key there is that when animals are sizing each other up to fight, they do something called antagonizing behavior. So they'll like, go, hey, sup. Okay. Oh yeah, that's pretty intimidating. Okay, great. Hey, check out my giant rack of antlers. See how big they are? I could really mess you up. Or yours are that big too. Hey, I can make big sounds. Can you make big sounds? Oh, that's pretty similar to. See how big I am? I'm going to turn to the side so you can see how big I am. See how big I am? That's right. Run away. So that's usually.
So some of they resolve a lot of the conflicts without actually having to fight to the death, because either one is good at bluffing because they have more confidence, or one is very self-aware and is like, ooh, that one's actually bigger than me. I know I can't take it. I don't want to try.
Yes. If males in these scenarios did not cut bait some of the time, the population would be halved constantly, right?
They would hurt themselves. They would die. Yeah, it would be no good.
And you would never get big enough to win, because ultimately you have younger males fighting older established males, and the younger males will eventually go, oh, I'm not going to win this one. And they'll leave so that they can then grow larger to then win later. Right. So this is key to competition within a species. Is you have to be able to have these antagonizing behaviors. You have to be able to size each other up and not always end in actual combat. So this brings us to hippos. The research suggests a couple of things. One being the reason that the males are around the same size as the females is that there's these territorial fights happen in the water. Elephant seals I was talking about before that are 6 times larger as males, they fight on land, even though they're not well suited to be on land at all. But they're on land, so they can size each other up. They can see how big they are. They can resolve this thing on land. Hippos are fighting in water where they're largely submerged. You can't see how big they are, but you know what you can see? How big their mouth and their tusks are. Speaking of tusks. So that's where Kiki's comment comes in. Hippos have giant mouths. So that is the antagonizing behavior that they use, is that the water reduces the advantage of large body size in a territorial contest, and instead the visual sizing up is forced on the yawning and the gape of the jaw, so that the size of their tusks and the size of their mouth is really what's important. The other piece of this research that's really interesting is based on what they eat. Hippos are vegetarians, they're herbivores. They get that big eating plants all day, or all night, I should say, all night. But when they do that, caught myself. But when they do that, the idea from this research is that there's kind of a carrying capacity for weight on how big you can get eating grass. So basically, based on their body mechanics, the fact that they're sitting in water, cold water all the time, that affects their metabolism. They're eating grasses all the time. And so this research suggests that they have reached a maximum body size, and they have reached that physical limit with their physiology in the size of a female. And so the male really doesn't have much farther to go.
Wow. So the males, they're like that's it.
Yes.
But the females could keep getting bigger if they wanted.
Probably a little bit, yeah. But
much,
then
though,
you have to figure in the metabolic input of being a mother mammal, which is a whole extra thing.
So there was a picture that you had up there of the teeth all looking like a bunch of tusks sticking out of the lower jaw there. And Daniel in the chat room is saying, I always thought their teeth were more blunt. Yeah, me too. I assumed they had big old like cow molar type things going on in there. And I with a couple, I remember seeing a couple of the big lower teeth before, but that picture you had up with one with its mouth open there. Yeah, it's a bunch of jaggedy tusks, I guess, poking out of it.
Yeah.
It's
So
weird.
they have these modified teeth that have become tusks that are specifically for this. It's for fighting with other hippos. It's for defending their territory as well, and it's why hippos are one of the most dangerous animals in the world.
So they don't do the food chewing thing? I mean, the cow is eating grass and is chewing food and has all this like 4 stomachs and all these things to deal with it. And this thing looks like it's. I don't even know what those tusk teeth would be good for.
But
they don't look like
see,
they'd be
that's
good for eating
exactly
anything.
it. That's what they're good for. They're not good for anything related to food.
Wow.
These guys are chomping on grass. So they have the flat molars in the very back of their mouth. They just have these modified incisors. They're not even canine teeth. They're modified incisors for this competition.
Poking each other.
Yeah, absolutely.
Competing
And
with the
that's
other
why
males.
they're so dangerous. They run at 35 miles an hour. They weigh 5,000 pounds, and they have teeth that stick straight out.
They run
So
how fast?
Heavy teeth.
Wait, they run how fast?
35 miles an hour.
Oh my
yes,
goodness.
so
I had no
sheer
They are a
momentum.
car
and then-
with a spear at the end.
Yeah.
Yes. 100%. Yes. So that's how most people die from hippos. It's because hippos are mostly aquatic. They sleep in the water during the day. They get out of water to eat grass. They make these pathways with their big flat feet that look like footpaths for humans. They're not. And then you are in between a hippo and water, which is the one place you don't want to be. That's a threat to them. They turn around, they open their mouth, they stick those teeth out, and they run. And
Okay,
that's
how fast
people-
can they swim?
They don't swim really at all. They walk on the river bottom. They're terrible.
Okay, so you might be able to outswim one better than you can outrun. I'm just saying, if I'm stuck between the hippo and the water, I need to know which way to go.
Yeah.
You're saying run to the water.
I don't know.
Because
I think you're in trouble either way.
It's the same. It's between a rock and a hard place. It's between a hippo and the water.
Yeah. Because also there's probably crocodiles in there if you're in Africa. But anyway,
what? It's does not get any better.
The bottom line of the story is
Halloween.
based on this found 60-year-old data set, we now know a lot more about hippos and how different they are from other mammals with similar social structures based on this one piece of evolutionary biology. And so there's this intense male competition, which was expected, but it does not pressure large body size. It just pressures that big mouth, those big honking tusks. And so the difference between males and females is not so much controlled by competition, but instead by environment, diet, and physiology.
Do the lady hippos, maybe I missed this, do the lady hippos have those tusks as well?
They do. They're not as big.
Might make eating easier. Maybe that's why they're bigger.
Yeah.
Let's move on from all this scary.
From stabbing to kissing? Is that what you want to do?
Stabbing to kissing.
Yes. So this might be spooky in its own way if you have a problem with small rodents, but prairie dogs, they greet each other with kisses. Imagine being kissed by hundreds of prairie dogs. So this is a study by University of Arizona behavioral ecologist Jennifer Verdolin. And she has studied prairie dogs for nearly 20 years. She has discovered that they have dialects, they collaborate, they have cultural differences between colonies. And so she has spent much of those 20 years huddled in prairies, hiding from prairie dogs in Flagstaff, Arizona, watching them from afar. She's watched them outrun predators. She's watched them learn speech patterns. And then the other thing that she observed and started to study was thousands of greeting kisses. So prairie dogs greet each other with a kiss, and individuals that kiss each other and don't fight afterwards belong to the same social group and territory. So this is potentially like a de-escalation thing. It's a recognition thing. There's lots of weird stuff going on.
It's like the European French hello, but then if it doesn't go well, then suddenly you're like, I don't know, in a Basque brawl. I don't know.
Yeah.
It's always awkward. It's always awkward. Oh, hey, nice to meet you. Oh, you're going in to kiss my cheek. That's nice, sir. I didn't know.
No, thank you.
Yes. It reminded me of that Friends episode when Chandler and Monica are caught kissing, and then he goes and he kisses all of the other women in the room on his way out the door. Anyway, moving on.
Great cover.
From this research, she's found that the more times they kiss, the stronger their connection. Makes sense, right? She observed 80 prairie dogs spanning 14 different social networks. And for a long time, prairie dogs have been assumed to have a hierarchical social structure. They're in most prairie dog literature, if you do some light reading of some prairie dog literature, you'll find that it says that there is a single male and a harem of females. That is not what was observed in this study.
That's
In fact,
wishful thinking by a researcher out there staring at prairie dogs week in and week out.
yeah, it's definitely it's a common thread in zoology where it's just kind of, that's the baseline assumption, right?
Yeah.
Is that the baseline assumption is that there's one male and a bunch of females, and like you have to prove me wrong, animal by animal, right? But anyway, point being, there's a bunch of males and females in these social structures, and not everyone gets kissed equally. There are community bridges, those that kiss members of neighboring social groups, so they're in with the neighbors.
Mm.
And then
Okay.
there are also hubs, those that get kissed by everybody, the popular prairie dog. And
The
so,
influencers.
yes, the influencers indeed. And so she mapped the intricacies of their social dynamics. She looked at how many friends they had, one of them had. That's considered a degree of centrality in social network analysis. And then looking at how many connections an individual prairie dog facilitated, which is known as betweenness centrality. And so in social network analysis, they found that, previously we found that predators, environmental conditions, food availability all contribute to the ebb and flow of social interactions in most animals, and that proved true here as well. So there was an ebb and flow in who was kissing who and how well it was received, essentially. And what's really interesting is that another kind of assumption made with prairie dog society, because they are pretty complex, is that it would be a fission-fusion dynamic, which is what you see in most animal societies that are studied for their social dynamics. This is where resources directly impact social behavior. So that means a group might split up to forage when resources are lean, maybe seasonally, and then they would come back together when resources are abundant. They don't want to overload one resource source. But what we saw with prairie dogs, they maintain a territory year round. They maintain a social group year round, and the amount of food that's available will change the way they interact with each other. It'll change the strength of those interactions and the frequency of those interactions, but it won't move the prairie dogs physically. It won't change their relationship to that space or those resources. It just changes the way they...
Yeah, so persisting in the same area over a long period of time, they have to have a stronger social network.
Mm-hmm. But it's a malleable social network.
Mm-hmm. It is, but it's opposed to like a migratory animal that might not have those connections to the neighbors. It might not have that sort of routine.
Yeah.
Fada has, I think, the best comment in the chat room there. When you kiss a prairie dog, you kiss every other prairie dog they've had contact with. Yeah,
that's right. Yes,
those
the individuals.
Mono goes through a prairie dog colony and their neighbors, just like a prairie fire.
So the reason this actually matters, other than just be like, oh, prairie dogs kiss, is that there's implications for conservation. So prairie dogs, their population historically was trashed in the 1970s-ish. I don't remember exactly, but their population was ruined because they were hurting crops, they were hurting people's lawns, and they all got poisoned. We tried to eradicate them, essentially. No surprises there. And so that impacted a bunch of animals nearby. All of the prairie dog burrows help with animals that need burrows. The black-footed ferret, I'm sure we've talked about on the show before and you've heard of, their population crashed because there were no prairie dogs to eat. So they actually impact about 100 species in their ecosystem. So the presence of prairie dogs can impact 100 different species that we've recognized of animals, right? So they have a pretty big impact on their space. So we care about these prairie dog kisses because this can impact the best way to do proper prairie dog conservation. A lot of the time, the focus is on having enough resources. Does this colony have enough resources? Great, it should do fine. But there's other factors. So how the animals are interacting, especially in high stress situations, might change how they respond to conservation efforts. So I think we talked about this a couple months ago, but behavior isn't usually integrated into conservation activities. The prairie dog kisses. So these are important for conservation efforts because what happens a lot of the time if people are wanting to do some construction around prairie dogs. If it's going to disrupt prairie dog landscape, they'll move them. But if you move what you consider a like social clique of prairie dogs, and you're not considering the kisses, then you might be removing bridge individuals that are connecting nearby colonies, and that can have a huge kind of domino effect on that prairie dog population as a whole. So if you're going to reintroduce or relocate prairie dogs, you can't just move them. The resources are not enough. You have to look at the population dynamics, the social structure, and consider that when you relocate these prairie dogs. So you got to watch them kiss. That's the bottom line. You got to watch them kiss. You got to write it all down. Who's kissing who?
You have to take the kisses with you.
You have to take the kisses with you.
Pack the kisses.
I'm going to reveal a little bit of ignorance. Where are these prairies?
They are in the United States. No, they're like
okay, so these are
the
western
prairie area. That's not.
There's prairies everywhere. Okay,
but
so
if you
these
think
are
about
like western.
home on the range, that's this area.
All right,
where the
okay.
cowboys were.
So you know what? Do the humans need to go everywhere? And construction
I think you'll find
everywhere?
that they do if you ask those mummies.
Just stay away. Just stay out of there. Stay out of the prairie dogs'
but
way.
sometimes you got to build a golf course, disrupt the prairie dogs.
No, you don't. You really don't. There's enough golf courses. Just stay away. Just stay away, people. Stay away. If you love nature, stay away. The traditional bison, buffalo grazing lands is also where this is. Okay. I'm sorry, I had to guess because I had no idea.
Where the buffalo
I'm looking too because this is very confusing.
Deer and the prairie dogs play. Where seldom is heard a discouraging word, 'cause those dogs have been kissing all day.
There you go.
Very well done.
Yeah. There we go.
Okay, everyone. You may or may not see prairie dogs wherever you are, but where you are right now is with TWIS. We hope that you are enjoying this show. It's TWIS-oween here. 2021. Woo! That in itself is scary. Don't be scared, though. Head on over to twis.org and get yourself a calendar and get ready for 2022. There's no reason to be scared of that. It's just another year, another calendar full of amazing art from Blair. So head over to twis.org. Get your calendar for 2022 today. All right, we're going to come on back now with some stories from Justin. It's your turn. What do you have?
I'm actually going to do I'm going to do one more story.
Okay,
I'm
just
dropping
one.
Dropping one here. The Falkland Islands. Have you heard of this before?
I mean, I've heard of them.
I have heard of the Falkland Islands.
Okay, without looking it up, where are the Falkland Islands?
Don't ask me geography.
Where's the Falkland Islands, bro?
I mean, they're in the middle of some sort of body of water because they're on.
Very good. Oh, well, okay, you're right. You know exactly where they are then. I actually doubt that most people could
not Hawaii.
Could pick out the Falkland Islands on a map. At least most Americans. If you're Argentinian or from the UK, you probably have a much higher chance.
Oh yeah, there's Argentina.
So these are small islands off the southeast tip of Argentina. They are thought to be one of the few places on the planet actually discovered by Europeans, because they were discovered to be uninhabited in 1690 by an English ship heading to Peru. It was settled nearly 100 years later by the French, and then the British, and eventually the Spanish as well. It was then abandoned and resettled again in the early 1800s by Argentina until a raid by the U.S. Navy in 1831 dissolved the government. A few years later, the British government took it over. Charles Darwin visited the Falkland Islands in 1833. He noted the unusual occurrence of a single terrestrial mammal species, a fox-like canid known as the Falkland Islands wolf, or the wara. In his journals, Darwin observed that the wara's lack of fear, its inquisitive nature, was likely going to class it with the dodo, an animal which has perished from the face of the earth, he wrote. 1876, the wara became the first canid to go extinct in modern times as a result of overhunting of this little fox. 1982, pretty recent history. The UK and Argentina engaged in an undeclared war over the islands, which lasted a little over 2 months. There were beach landings, there were boat bombings, planes firing on each other. This was an actual war between the UK and Argentina. Most people don't think of as one of the great wars because it all took place in and around these islands. And, the British won that one, as one might imagine. So, anyway, this is findings from totally unrelated. Findings from a University of Maine-led study are suggesting human activity on the islands predated the British discovery by hundreds, if not thousands of years. This is Kit Hamley, National Science Foundation graduate research fellow, led the investigation. She and her team collected animal bones, charcoal records, and other evidence from across the islands over multiple expeditions and examined them for indications of human activity using radiocarbon dating and other lab techniques. One of the notable signs of pre-European human activity derived from an 8,000-year-old charcoal record collected from a column of peat on New Island, one of the names of the islands, New Island, located in the southwestern edge of the territory. According to researchers, the record showed signs of marked increase in fire activity than 150 years, BC, or no, AD, 150 AD, and then abrupt significant spikes in 1410, and then later in 1770, which would have been when the sort of European colonization events were taking place by the French. Researchers gathered sea lion and penguin samples on New Island near a site where a landowner had discovered stone projectile points that were consistent with technology of indigenous South Americans over the past 1,000 years. And they found that these bones were sort of heaped in piles that looked like kind of mounds that would be created by humans who were hunting and then taking them back to a specific point and dismembering them for food. So it looks like the indigenous South Americans likely traveled to the islands between 1275 and 1420. And prior dates can't be ruled out because there's some evidence that thousands of years, 8,000 years earlier, there may have been human activity. One of the things they also found was they found a tooth from one of Darwin's extinct Falkland Island foxes, the Falkland Islands wolf. So this is also one of those things that one of the questions was, is this lone mammal that Darwin finds in 1833, is it actually a native or could it have been brought there and released? And that's maybe this had been domesticated type of a fox and that's why it wasn't afraid of people. But no, this tooth dates back about 4,000 years. So, I'm sorry. Actually, what would it be? 5,450 years BC.
Wow.
According to the radiocarbon dating. So, this little fox somehow ended up isolated enough on this island to become its own species, and had been there. Now we have the oldest record of it going back, 5,500 years
Before people.
But, well, yeah. Or maybe the people had been there also, even going back further because there's some evidence. But they think that's what it was. It was, it would have been an island that humans would go to for short stays. They would go there, do some hunting and fishing in the area, but eventually return to the sort of mainland. But if they can find the 8,000-year-old evidence, again. This is a people, right? This is a people who colonized 2 continents. It would be really weird if they didn't keep exploring.
Keep moving. Keep
Yeah, I
going.
mean, this is an island. This is an island that the settlers, the Spanish settlers throughout Argentina and the Americas and stuff, hadn't known was there. Even didn't even know it was there. Like, they got discovered by accident because a British ship was going by and it was like, "What's that? Ah, it looks like land." And went to check it out. It's like, "Oh, that's not where we're heading." But they, they went and kind of checked it out and took a little bit of inventory of some of the life forms that were there. But
and said, "Let's plant a flag. It's ours now.
We'll come back later." And then the French went there first. So yeah. I have no doubt. I have no. So but there was a. Does anybody know about the Falklands War? Like, I feel like I missed that one. I would have been a child at the time it was taking place. But the UK and Argentina at war with each other, like battleships,
so hard to consider.
planes, like beach landings, the whole thing. Crazy.
It happened.
And I think the population on the islands is something around 3,000. Like, there's not, like, I don't even, like, there's not, like, why are you fighting over that? Stop it.
Because it's land and we could put things on it.
Yeah, I guess so.
Resources, land, it's important to somebody. Oh, my goodness. I have a couple of brainy stories to finish us up.
Nice.
Oh, good.
Yeah. So,
Brains!
brains! Yes. Got brains. My zombie tank girl is coming to get you. Brains. Back when I was in graduate school, I studied bird brains. And one of the questions we were interested in the Clayton lab where I worked, was whether or not the brain was prepared in some way, the little baby bird brain, whether it was ready for experience, whether it just grew on its own, or whether it was like, as soon as it got an experience that related to spatial memory, whether storing food or navigating, whether that caused or allowed for growth. And all the evidence seems to point to, in the birds that we were looking at that were food storing birds, and also in birds that were migratory, it's like as soon as they get that experience, it's like the hippocampus in the bird brain is just sitting there, little, doing normal little hippocampus things. And then you give it one seed to store and it proliferates, and suddenly you have neurogenesis and the brain grows. And it's like, wow, okay, this is a really interesting adaptation for energetics. And also because birds, they have to manage their weight. And so if they're not going to have those experiences, maybe they don't need to put the energy into it, right? So how many other species have this kind of preparedness in their brains, the waiting for experience? Some researchers at Drexel University just published in a journal called The Science of Nature. And I actually had to double check that was a real journal, because I was like, really? This isn't like a kid's book or something?
Or just somebody making it up because there's a journal called Science and a journal called Nature. They're like,
let's call it The Science of Nature.
The Science of Nature?
Yes. But they have published their study looking at neural expectation in termites. Turns out that termite brains are ready to go when they need to for the right opportunities. Termites have castes, right? It's a hierarchical, stratified population where different portions of the termite colony have different jobs. There's kings and queens that at some point get wings and they get to go out and fly and be free and reproduce and then go make a new colony and turn a new thing. And then there are others that don't get to fly away. They still get little wing buds, like they kind of wanted to almost fly away, but they never got that chance. And so which of these termites is getting ready for the right experience for that ability to take advantage of going out into the wide, wide world, leaving the colony and exploring? Well, these researchers looked at termite brain tissue, and they determined that the termites are investing in brain regions that are their purpose, their function is to deal with the cognitive demands of flight. And this happens before that experience actually happens. So it's different from the bird brains where the experience happened and then neural proliferation happens. In the termites, they're like, which one of us will it be? We all must prepare. And so the termite brain gets ready to go, whether or not the termite's going to end up out there.
So are you saying, is it a matter of free your mind and your wings will follow? Or is it
Yeah.
like, interesting. So is it really just come down to peer encouragement, peer pressure? Like, yeah, sorry, son. I wish you were going to be a flyer, but nah, you'll be working in the wood mine with your old man. Till the day you die, he'll never have wings and fly. Make your dreams smaller.
Right?
And then
You're
it's
never
like,
gonna go. You never get to do it.
I guess if that's the case, I just won't grow wings. I mean, like, that's weird. Like,
they've already gotten their brains kind of ready. They're ready for the cognitive demands, but then they don't have to, and the wings don't have to grow, and the stuff. They never make it past that kind of nymphal stage, and they just become regular colony adults, and they don't get to fly.
If you want to go very new age with this, I feel like you could say that this is like, the goldfish syndrome, but for your brain, right? Like your brain is going to grow to the container you put it in, right? So like reach for the stars and
then again, son.
To do more.
If you don't have wings, you can't fly, but then you're not going to, the chances of you being eaten by a bat are much less. It's not all bad. It's not all bad.
It's true. These termites, the ones that aren't flying, they're mostly going to get eaten by what? Honey badgers? Bears? Yes. They're going to be eaten by those animals that want to dig into that dead tree meat.
Kinkajous? Who knows?
Kinkajous? Oh, fantastic. Yes. Yes. Well, the kings and the queens that make it into the outside world, they are ready to take up their ruling status. Their wings, their vestments of greatness, as well as their brains. They're ready to travel. Da, da, da. Okay, now moving on into why are we afraid of things sometimes? How do you, when you walk into a building or a new space and you're kind of like, oh, it's super creepy. What's going on around here? You know how sometimes you just get goosebumps for no reason that you can consciously explain. You're like, I know it's fine. Everything's safe, but
it's just a bank. But something about the people here is just unnerving me.
I was going to go much darker with it and say, you mean like every time that I walk around at night by myself as a woman? Oh, no, wait, there's a reason for that one, though.
Well, it's dark, right? There's dark. It's also being alone, not having, being a woman outdoors alone in a city area. Yeah, okay, all these things. Beyond even that,
it's more like that plant is making a scary shadow and now I'm creeped out.
Yes, exactly. So researchers at the University of Toronto have been interested in what are the basic components that lead us to have certain feelings even before we are consciously aware of the things that are around us in a particular space. And so they did a study and determined that individuals, we process particular features of danger very quickly without conscious control because it helps us avoid danger. And we know that this is true. Like a snake, maybe you don't know it's a snake, but you see a long vertical shape. You go, oh, you jump away from it. And then you look back and you go, oh, that was a stick. But if you are lucky, you go, I didn't get bitten by a cobra. That's great. So they looked backwards to see all this. They published it in scientific reports, and they found that there is an emotional aspect to very specific features. They used a picture set that is used in psychological research all the time. It's called the International Affective Picture System, and it's a database of about 1,000 images from people to beaches and furniture in rooms to things that are actually disturbing, like natural disasters.
And banks.
And banks, things that evoke different emotional response. And researchers use them in psychological studies when they do want to evoke particular emotional responses. Well, these researchers took away all of the color context. They took away all the stuff that was the real stuff in the pictures and left lines. All that were left were lines. And they found that people viewing these pictures that just had lines, vertical lines, horizontal lines, broken up, jaggedy lines, long, open, free lines, they had emotional responses in the same exact way as to the full contextual content.
Wow.
That's
so
cool.
The subconscious brain is able to either reconstruct the image, but not necessarily translate it to the conscious brain, but still react to it on the visceral level?
Yes.
Wow.
Exactly.
So if I'm not wearing my glasses, I would be equally creeped out, even though everything's fuzzy.
Exactly. You would. You'd be like, okay, it's fuzzy, but I know that that's jaggedy, or this is whatever. And so when they took everything out, they found that the lowest level features that were able to trigger emotional responses were consistent across types of landscapes. So open horizontal lines, which remind us of landscapes, of beaches, those seemed to give positive affective emotions. Whereas, like I've said a couple of times already, like jagged, broken lines are short, angular, are negative and threatening. Mm-hmm. So just taking out all the other context, these very basic aspects of imagery can affect our emotional response to things that we see. And we don't even know why. It's just lines. We're like, my intuition.
Like
yeah. And so the question, because we have this thing going back, people, babies are afraid of snakes, right? We have these kind of built-in fears. And so the question is, at what point are these fears that are actually genetic, that are wired in from birth, and which are learned, and what components are genetic and what components are learned in the way that the circuits are all wired together. So, long, open, horizontal lines leading to positive, happy, it's turning off your amygdala, making things happy and fuzzy, or, the jaggedy stuff turning on your amygdala, making you angry, afraid. These are very interesting questions.
I'm sure they're very deeply ingrained evolutionarily. Yeah. I mean, it would make sense. So I was thinking about, not to bring it back to, my trip and everything, but I was snorkeling and we were around a bunch of fish. There were a bunch of like reef fish and it was awesome. But there was one moment where there was this huge school of fish and they started kind of moving erratically and splitting apart. And I felt my heart rate increase. Like, I knew I wasn't about to get eaten by a shark. I know.
Did you?
But
did you?
I know that that's extremely unlikely.
Really?
Did you really know that it couldn't happen?
But something about the way the fish were moving kind of got my heart rate going. And think about it. We came from fish. So if the fish are scared,
suddenly
there's probably something very deeply ingrained in me to know if a prey animal is scattering, that's not good. Of course, I had to remind myself, like, oh no, they're probably doing that because I look like a predator. But
I'm the bad guy.
There's still, this piece that's very visceral. That's okay. Something's amiss. And evolutionarily, there would be a benefit to responding to that and to responding to, I guess shapes that indicate bad stuff. There would be a huge benefit to that.
Yeah. I think it's, our conscious mind is too slow to keep us alive. It has to be faster.
That's absolutely
what are the
true.
things? Yeah. So now it's figuring out what are the things that are affecting the unconscious mind and making us react before we're ready. And I guess, yeah, so many questions about it. So many questions. But as we head into...
I was going to say, too, quickly throw in, you got into a conversation with somebody who does dream studies.
Yes, I did. Yeah,
So
there have been a couple of great studies, great
That's
interviews
up on the website now. Yeah. A recent interview with somebody who says, it wasn't part of that, like, I don't know if it was covered in that, but yeah, like, the people who have sort of premonition type dreams, oftentimes could just be that subconscious brain, which is capable of much more than it can translate to our tiny conscious ape brain. Can do a lot of insane calculations. Mm-hmm. Probably does a tremendous amount of predictive power, constructing all the known events of our current reality with the possibilities, and then pick some stuff out. Then you dream it. You dream it through a little bit. It spills over. Now, if your dream doesn't happen, if the things it's playing with, the running possible futures, doesn't pan out, you don't think twice about it. Now, when it hits, you're like, oh, I had a premonition dream, because it totally says. But it's probably the brain doing that all the time, trying to have that predictive of best or worst fears, or things that could happen that you hope for, or things that you hope won't happen, can happen in dreams as you're sort of playing with the scenarios. I like this study because it's showing that there's a part of your brain that is much smarter than you. And maybe if there was a way to tap into it, if there was actually a way to elevate that part of the brain, we would just all go insane immediately by having too much fear, predictive insight into what's going to happen next.
And Kev B in the chat room brings up a really important question, which is, can this research make haunted houses more scary? Which I bet that it can.
Yeah. So, I mean, if you can take advantage of the angularity, of sharpness, of broken angles and broken lines. Maybe
you know who does that?
Your haunted house scarier.
You know who does that magnificently? Tim Burton.
Yes.
Oh, yeah.
Yeah, there's something definitely to look in. Look at your favorite horror movies. Look at your, the things that make you fearful. Look at the things that make you feel comfortable and happy, and take a look at them from this perspective of how they're constructed. Try and break them down a little bit in your heads. But it's Halloween, so we're all about scary. All the teeth, big fangs, big fangs. Big tusks.
Pointy teeth.
Pointy hippo tusks. Ah. All right. Have we done it?
We've done it.
Yay.
We've done it.
Ooh, you might not have thought we would have made it to the end of this haunted episode of TWIS. But we have. We made it. And I would love to say thank you to everyone for joining us for this Twissoween episode. We do hope that you enjoyed the show. And I would like to thank people who have helped the show. Thank you to Fada for helping with show notes and show descriptions and social media. Thank you to Identity4 for recording the show. You picked up a couple of episodes last week separately, which was very awesome. Thank you for doing that. Thank you for everyone who helps in the chat room to keep the chat room calm and polite and happy and, maybe a little bit spoopy in this episode. And thank you, as always, to our assistant, Rachel, for helping us out, get our TWIS calendar dates together, for editing the show. She also has helped with a couple of extra episodes this week. And thank you. Thank you to the TWIS patrons for supporting TWIS. Thank you to Kent Northcote, Rick Loveman, Pierre Velazarb, Ralph E. Figueroa, John Ratnaswamy, Carl Kornfeld, Karen Tozzi, Woody M.S., Andre Bassett, Chris Wozniak, Dave Bunn, Vegard Shefstad, Hal Snyder, Jonathan Stiles, a.k.a. Don Stylo, John Lee, Ali Coffin, Maddie Perrin, Gaurav Sharma, Shu Brew, Don Mundus, Stephen Albaran, Daryl Myshak, Stu Pollock, Andrew Swanson, Fred S104, Sky Luke, Paul Runovich, Kevin Reardon, Noodles, Jack, Brian Carrington, Matt Bass, Shauna Nina Lamb, John McKee, Greg Riley, Mark Hessenflow, Gene Tellier, Steve Leisman, a.k.a. Zima, Ken Hayes, Howard Tan, Christopher Rappin, Dana Pearson, Richard, Brendan Minish, Johnny Gridley, Kevin Railsback, Rami Day, Flying Out, Christopher Dreyer, Artyom, Greg Briggs, John Atwood, Hare, Arizona, support Aaron Lieberman for governor, Rudy Garcia, Dave Wilkinson, Rodney Lewis, Paul Mallory Sutter, Philip Shane, Kurt Larson, Craig Landon, Mountain Sloth, Jim Drapose, Sarah Chavez, Sue Doster, Jason Olds, Dave Neighbor, Eric Knapp, EO, Kevin Parachan, Aaron Luthen, Steve DeBell, Bob Calder, Marjorie, Paul Disney, David Simmerly, Patrick Pecoraro, Tony Steele, Ulysses Adkins, and Jason Roberts. Thank you for all of your support on Patreon. And if you are interested in supporting us on Patreon, please head over to TWIS.org and click on that Patreon link on next week's show.
We will be back Wednesday, 8 p.m. Pacific Time, broadcasting live from our YouTube and Facebook channels and from TWIS.org/live.
Hey, do you want to listen to us as a podcast? Maybe while laying on some island's beach? Just search for This Week in Science wherever podcasts are found. If you enjoyed the show, you can get your friends to subscribe as well.
All right, for more information on anything you've heard here today, show notes and links to stories will be available on our website, www.twis.org. And you can also sign up to go at sea with me as your captain. Just make sure you bring your plenty of rum, a barrel of rum, and maybe something to eat. I didn't really plan ahead.
Bring science!
Bring some science stories.
You can also
bring the
contact
science!
us directly. You can send us some electronic mail at Kirsten at KirstenThisWeekinScience.com, Justin at Twisted@gmail.com, or me, Blair, at BlairBaz@twist.org. Just be sure to put TWIS, TWIS, in the subject line, or your email will be spam filtered into a haunted house filled with mummies and teeth.
You can also hit us up on the Twitter, where we got at with science, at Dr. Kiki, at Jacksonfly, and at Blair's Menagerie. We love your feedback. If there's a topic you would like us to cover or address, a suggestion for an interview, a bat that comes to you in the night, please let us know.
Oh, a bat. Yes, let us know. We'll be back here next week, and we hope you join us again for more great science news.
And if you've learned anything from the show, remember,
It's all in your head.
This Week in Science. This Week in Science. This Week in Science. This Week in Science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. 'Cause this week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth. And I'll broadcast my opinion all over the earth. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 This Week in 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 Science.